And today I'll be presenting to you the process of creating a shadow study for the exterior of a building. Shadow study means to determine the effect that the movement of the sun has on objects on Earth, such as how and where the shadows are pointing to at different times of the day and during different seasons. So I'm pulling the information from two separate chapters of the Autodesk 3ds Max 2021 Fundamentals Training Guide from ASCENT. And these chapters are like chapter 10, which is the exposure control, daylight, and rendering chapter. And I'll be talking about creating the sun positioner from this chapter. And then I will also be pulling some information from, which is the animation part of the shadow study, from the Appendix B of the guide. So all the information that I'll be sharing with you today is in the Autodesk 3ds Max 2021 Fundamentals Training Guide. So now let's start with the objectives for today. So we'll be creating the daylight system using the sun positioner and physical sky. We'll be modifying the parameters of the sun positioner. Then we'll create renderings during different months and at different times of the day. And then finally, we will animate the movement of the sun positioner to create a shadow study. So let's talk about sun positioner first. So we all know how important sunlight is, and we also know that the sunlight affects the energy performance of the buildings. So sun study of the shadow study for buildings can be very important in the architectural industry. It determines on which side of a given building the sun will rise, and then also determines the movement of the sun during the day and how the shadows are going to be cast. In 3ds Max, you can very easily perform shadow studies, especially using the sun positioner. So a little bit about before the sun positioner, the new system of sun creating a sun in 3ds Max, it was introduced, I think, in 2017 or so. Before that, we used to have daytime lighting, and these to add the sunlight and the skylight system both. So that system had many different components, and they were scattered all over the software. So, but now after adding the sun positioner, it's pretty streamlined and extremely easy to use. So for today's presentation, we will we'll use the sun positioner, and it's always recommended to use sun positioner. And plus it is also, even if it's meant for Arnold renderer, but it can be used with any other renderer in the 3ds Max. So you don't have to actually worry about like whether it will work perfectly with other renderers. So for today's presentation, we will animate the sun positioner object to create the shadow study. Now it's located in the create command panel under the light section, as you can see here on the screen. So this is the create panel, and then the light section under the photometric lights, the sun positioner is right there. So it's pretty easy. Like it's just one, we use just the sun positioner to create the sun. Now, creating a sun positioner it's just a 3-click process. So first click, it sets the compass rose. The second click orients the sun, which means sets the cardinal directions like north, south, east, and west. So that we know, the software knows on which side of the building the sun is rising and where it's setting. And the third click, it sets the distance of the sun, as you can see on the right hand side. So the first click will create this compass rose, and the second click will just set the directions, and then the third click is just the altitude of the sun. As with other 3ds Max objects, so this sun positioner is just an object, a 3ds Max object that we created by those 3 clicks. So as with other 3ds Max objects, we can also modify the settings of the components of the sun positioner by changing the parameters in the modify panel of the object. So first of all, we have the display rollout. So once you go into the modify panel, selecting the sun positioner on the screen and then going into the modify panel, we can change so first of all, we have this display rollout. And in this display rollout, we can modify the radius of the compass rose. We can also change the orientation of the cardinal direction by using the north offset. And we can also set the distance of the sun. So we already did this using the 3 clicks. But then if we want to modify it, for example, we said we didn't set the right north direction, or we didn't set the right way where the east of the building is, we can go in here in the north offset and just modify it. Again, the distance of the sun, like the altitude of the sun to begin with, we can just set it here again. The compass rose, how it shows on the picture on your screen, you can set its radius here. Then these are the main, the next one is the sun position rollout. And here you have to control just a few things, and you can modify only just a few things for the sun positioner. Otherwise, everything else is really automatic for sun positioner. It takes up all you have to give it is the geometrical location, like the geolocation of the building. So you can select it here in this location of the earth, and you can select, it's just like selecting the place where you want to create the shadow study. And it's as easy as selecting the location of the map. So if you have the exact if you have the exact latitude and longitude values of the location, you can also use them here. So by giving the latitude values and the longitude values here. Otherwise, all you have to do is just go on to the, like where it says Portland here. When you click it, you will see the map, and on the map you can choose your location on Earth. Then also you have to choose, the next thing you have to set is the date and time you want to check the shadows for. So rest, it automatically calculates the azimuth values, the altitude, and even by clicking, when you click the location on Earth, it also automatically gets the latitude and the longitude values. So, and the time zone as well. So it doesn't matter. It is very intuitive to the user. So all you have to do is set the location, set the date and time, and that's about it. So once you have set it, then we start rendering. So before we animate the sun positioner to create a shadow study, it's recommended to create a rendering and see if the rendering is okay. You might need to set some exposure values, but with the sun positioner, all the exposure controls are also automatically set and it also gives the background is also set automatically. So you don't actually need to do anything. But you still have controls, like if you want some artistic controls to add like a tint or add like fog or something like that, you have that, but that is just later on if you want those artistic controls. But off the bat, it is pretty easy, and it just sets everything for you after you set your geolocation and after you set your date and time. And once you render, it will give you the rendering. So here, as on the screen, you can see the 2 renders that I have put in, and one is at 7 a.m., which is in March. And so that shows you how the lighting is going to be and where the shadows are and how much light there is. And then at 12 noon in March, you can see where all the shadows are, how it is affecting, how much light is coming into the building, and how much interior lighting you need to set. So this comes in very handy for those reasons. And plus also, if you know that there is that lighting analysis can be done, so this gives you a very important or information provided to all the architects and everybody who are just starting to make the buildings and seeing how the sun is affecting, how the shadows are affecting that building. So the next part is actually animating and creating a shadow study. So now so animating, it's just simply as we use the animator, like how we animate any other object, we animate this sun positioner as well in a similar fashion. So we open the time configuration dialog box, which is, as you must be knowing, that it is in the animation tools on the screen. And from there, when you click that icon, you get the time configuration dialog box. So here you can set the frame rate. A frame rate can be NTSC, film, PAL, or custom. So as we know, most of you must be aware, if you have done animation before, you must be aware of what these frame rates are. It is just that how many frames to show per second. So NTSC is the television. In television, they use 30, it's generally used 30 frames per second. PAL is meant for the European areas. So there they use 25 frames per second, and film is about the film industry. It uses around 24 frames per second. But for a desktop-based, like desktop and web-based productions, the custom frame rate works well. So we will set it at custom, and then it's generally between 12 to 25 frames per second. So you can set anything between 12 to 25 is considered good. Then you can set the rest of the options, like the time display. Do you want in frames or SMTP, SMPTE or others? And then also you can start the animation. The important thing is setting the start time and the end time. So start time is generally at 0. We start from frame 0, which is the first frame, which is going to be the first frame, and then the end time. We need to give it a end time. So in between that, it will animate automatically, will animate the sun positioner. So next is, so again, now how to animate the sun positioner. So first of all, we'll put the time slider at 0 location. Then we will set the starting time of the sun shadow study. So we must have set the location, and then we have to just specify from which time we start the sun study, and after we are done animating the whole process, then we will give the end time. So here, for example, we have given 6 hours, which means that it is 6 a.m. in the morning. So that we start our sun study from 6 a.m. and then set the auto key. We click the auto key, and that shows that now we are animating. We are keyframing the sun positioner. Then the next one is time slider at the end location. Then we click and drag the time slider to the end location, and then we set the end time. So for example, we can set 7 p.m. So which will be in hours. So we have to set everything in hours. So 7 p.m. will be 19 hours. So we have to set 19, and then we clear the auto key. So it shows that it will automatically create the position of the sun. It will rise, and then it will set, and then give renderings at each one of them. It will just animate it. Then we have to set the render parameters to render all the different, all the various frames during this whole animation. So these keyframes need to be rendered. And so in the rendering parameter, we will save it to image files. And it is done through the render setup dialog box. Most of you must be aware of it, where to find the render setup dialog box. And as normally you would render, you would set all the options in the render setup dialog box. You would do it for the in a similar fashion for the sun positioner as well. So here I'm showing like just two images up on the screen. One is the shadow study at frame 1, which is at 6 a.m. for the same for the exterior of the building, and then we have the shadow study at frame 30, which is the last frame. I had kept it at frame 1 and frame 30, and that is at 7 p.m. in the evening. So you can see how the sun is creating the different shadows because it's falling from the west. Now it's setting from the west, and then it creates those long shadows. And in the morning, you can see it's setting from it's rising from the east, and then how it is creating those shadows. So that's the two images. Now we will just go into software demonstration. So here I have the same building, which I was showing the exterior of the building open. And now I'll show you in the software demonstration here in the software how to create the sun positioner, and we will animate it also here. So, so let's start by putting it in the create panel. In the lights section, we have the sun positioner. It's in photometric, and we have the sun positioner. Once we click it, we will start positioning it here in the top viewport, which is most easiest to do. So let me first, so maximize the top viewport, and then let me get to the whole area. So this is the building right here. And then these are the parking spots. This is the corridor coming from behind, and so on and so forth. And so let us start to place the sun somewhere in the middle, the compass. So let me start from again. So sun positioner, and so let's start. So this is the compass rose, as you can see, and by moving my cursor, the first click will set its position. So we can always change the length and the radius of the sun of the compass rose, and it doesn't affect in any way. It's all that it is visually, I can visually see the compass rose. So that was the first click, and I set it. And now the second click is for the cardinal directions, where to put the cardinal directions. So as you can see, I'm putting it like east on the right hand side. So the sun will start rising from on the right side of the building. So let us put the cardinal direction. That was my second click. And the third click now is the altitude or the distance of the sun from Earth. So all you can do, I'll go into my left viewport, and then it will be easier there to show you how. So let's go back into top viewport. I think something happened here and I missed it. So let's start here. So place the compass rose, and then it's too big, but we can set everything later. And then let me put the height and for the time being, and now let's go here back here. So let me change the radius to 7 to make it more visible. So there we go. And then we have to set the north offset because I want this on the east. And then let's set the distance of the sun to something as 300. Right here. So that's it. So we set everything. So what we can do is go maximize and see the 4 viewports. And now we have set our east position. North is on the back side of the building. And the next thing we have to do is animate the sun positioner. So as you can see, the sun positioner is already selected right here. And all we have to do is just, first of all, open the time configuration dialog box and set our frame rate. So we'll set it at custom, and then in the FPS, let's keep it at 20. And that will create 20 frames per second. And from the start time can be 000, and let's leave it at SMPTE, and the end time, let's put the end time to 30. And then we can go OK. And as you can see on the track bar down here, it is from 0 to 30 here, right here. So at the first location, what we have to do is, again, go into the modify sun positioner, and only difference is that we will change the sun position right here, the distance and the place where we are creating the sun study for. So we can just go into click on San Francisco, and maybe because I'm located in Canada, let me go and find something close by. So let me find Ottawa in Canada. So let's go and find O. So right here is, this is Oshawa, that's Ottawa in Canada. And as you can see, it is located, the plus sign is located here, and then we are creating the sun study for Ottawa in Canada. So it is as easy as setting, just clicking on the place you want. Now, if you want to have, to get the exact position of the building, so you can have the latitude and the longitudes. So if you have the exact position, latitude, you can always enter them here. So just a little bit of a tip is that your latitude, if it is in a positive, if it is positive number, if latitude is positive number, it shows that it is on the north side of equator. So places which are on the south side of the equator, the latitude will become negative for those. And the longitude is negative because it shows from the east and the west side of the prime meridian. So because North America is situated on the west side of the prime meridian, so it becomes negative. So places which are on the east side of the prime meridian, like if you want to have Australia on your map, so it will show positive there. So, but for any location, for example, we are choosing Ottawa here. If you want to have the exact place to the last degree, you can just have the latitude and the longitude for that and enter them here. And based on this, now based on the day and month and the time of the year and the season, your azimuth and the altitude values will change accordingly. So you don't need to have the exact, because it's not so intuitive, and in general layman's language, you don't know what the azimuth values are, what the altitude of the sun at that moment in time during the day will be. So it's so easy here. You just have to set the day and the time. So for here, we have set it for the 21st day of June, 21st of June 2020. And then we will start our shadow study from 6 a.m. So we can enter 6 here, which will be in hours. So we'll start our shadow study from 6 hours, so which is right here. And we can set the auto key now. So we are setting the auto key. Now we will drag this to the end position and have the end time till where it will end the shadow study. So let's have it at 7 p.m. in the evening, so which will be 19 hours, and set it at that. So once, if you can see, I'll scrub those. Now this has been set, so it has already animated the sun positioner. It calculates all the different positions automatically. So if I scrub, and you can see in the left viewport the movement of the sun and the altitude of the sun positioner. So it automatically calculates. It's so easy. It's just click of the button and it's done. So all you have to do is scrub, and you can see at what position the sun is, what the altitude, the azimuth. And as I'm moving my time slider, notice the azimuth and the altitude values. They keep on changing. So right there. So once this is done, so this has been calculated. So all I have to do is clear the auto key, and it will save all those animation of the sun positioner. So then what we can do is, but let me go back. Now we can render, now we can set up, set the various values and parameters for the render setup dialog box, and that's right here. So we are using the Arnold renderer, and we are using the quad 4, not that one. We will be using the camera viewport. I have already set a physical camera right there, and we will be animating that for the shadow study. So we'll choose that camera. So one more thing before I can say is that you have to go in here, and you should always press escape. Otherwise, it will start creating a new sun positioner because it's still on. So wherever you click, it will create it. So if you don't want to do that, we don't want two sun positioners in there. So we'll just press escape and just let it go. So then here in the time output, we will not, because we don't have that much of time right now, so we can always go for active time segment. This is the regular way you will be setting your render in your parameters in the render setup dialog box for any regular kind of animation that you will be doing. So let's do every fifth frame, and between, so there will be, let's start with fifth frame, every fifth frame, and then let's go, the width and the height are okay. And all we have to do is set the file here. So once, because it will save all the different, at the different locations, at different frames, it will save the image files for that. So once we get into the files, we choose the location where we want to save. So we'll go into C drive and save it at a location wherever you want to. I have already saved it. I don't want to save it right now, but I'll show you exactly where I have saved those. So in the test, so all you have to do is enter a file name. So I have already used a shadow here. So we can use the sun, saying sun dot, and the format should be, you can choose any of the image formats. I'll be choosing JPEG right here. And that's about it. And once I say save, it will give me the JPEG image control. So I'll just keep the image quality as best and say OK. And then once it's all set here, I can say render, and it will start rendering. So let me just press render, and we can cancel it if it takes a little longer. So you can see it started rendering each frame. So here in the rendering dialog box, you can see there are 121 in total. In total, it will create 121 images, and it's still doing the second one. So right now, we will just cancel, and I'll show, but you can have a look, see how it is changing, and it is creating each frame, each image for each frame, whichever the number of frames that I have asked for. So, and you can see the changes in the lighting in the frame as it's rendering each image. So see how the light is changing slowly. The shadows are falling. So at this point, I'll just cancel this because we don't have that much of time, and I have already created this one. I'll open that in the frame file as I was showing you, those shadow images. So this is the first one, which was at 6 a.m. Why isn't it opening it? So as I had already shown it to you, I think something is not right now. So all I have to do, I'll just go back. So I'll go back into my PowerPoint and let me go up. So right here, as I had shown you, these are the frames, shadow frame and frame 1, and that was the frame 30. And in between, all the images were right there. I don't know why it's not opening right now, but I think you got the gist of it, how to create a shadow study. So let's proceed with the summary. To summarize, today we were able to create a sun positioner. We were able to locate the position on Earth. You also will be able to set the day and time of the day, render the images at different times of the day, animate the sun positioner by keyframing it, create the rendered images at different keyframes, and save the rendered images to the sequential image files. So that's about it. If you want to, I'll just go back into and quickly show you that you can create a film also of all those image files continuously to show different. Once you create, all the image files are created, all you have to do is, if you want to create a movie out of that, all you have to do is go into animation, rendering, and go here, compare media in a ramp layer. Once you open that, why isn't it showing? It's on my second screen, I think, and my screen is not here. So there is a dialog box that will come up, and in that dialog box, you will be able to set a movie as an AVI file, and that movie will be created for all the images that you have set. So hopefully, I think we are done with the presentation, and I'll pass it on to Corinne, and she can tell you about the different formats for our learning guides.
Excellent. Corinne. Thank you, Renu. Yes, can you hear me?
Yes.
Okay, great. So I was on mute there for a moment. So just to remind everyone again, Renu, what the exercises that you were showing were from what training guide?
It was in Autodesk 3ds Max Fundamentals 2021 guide.
Perfect. Okay. Yeah. So I just want to let everyone know that that learning guide and any of the learning guides that we offer from ASCENT are available in these following formats. So we have printed guides. We have the same content in an ebook format. So if you don't want the printed book, you can have it in a digital format. We also have e-learning bundles as well, where you can get several of our courses basically in an online format when you buy one bundle. And then if you are tasked with teaching other people, either coworkers or you work for an Autodesk training center and you're an instructor, then I highly recommend that you purchase the instructor guides, which will give you a copy of the learning guide, but it also includes all of the questions, includes the answers to all of the questions that are within the guide, and also gives you some timing suggestions for delivering the course. And in many cases, we also include instructor presentation files as well. And then just our last slide up here, I'd like to show everyone all the different ways that you can reach out to ASCENT. So we've got our website, ascented.com. On that website, you can go there and look for Autodesk and then find the software you're looking for, search down by version even, and then you can see all the different courses that we have available, or you can go right to the ascenteStore.com. So either way, you can purchase our books that way. There's our phone number, and if you have any questions for us, you can contact us at feedback@ascented.com.